How many of you guys, just with a raise of hand, how many of you guys, your brain seems to latch on better and feel more secure and safe by writing everything out? Okay, 2, 3, 4. Okay. Is that a valid way to get negative 22? Yeah, completely. Completely valid. Which of you guys think by pointing, or at least thinking of pointing and then adding, you'll still be able to get there? Or you might even prefer it? Okay. Now, did I still write down some stuff? Yeah. Now in my head, technically, when I was getting this negative 22, I was just doing negative 1, minus 6, minus 15, and I was keeping track of it in my head. Is that dangerous sometimes when you're doing it? Or even when I'm doing it? Yeah, it's dangerous. Why? Yeah, sometimes you get big numbers. Sometimes you have positives and negatives. Or technically, guys, how many numbers could we have to keep track of depending on the size of our matrix? A lot. What if, for instance, this was something like a 2 by 10 and a 10 by 10? A 2 by 10 and a 10 by 10. How big would that answer be? First of all, would that even be legal, 2 by 10 and a 10 by 10? Why is that legal? The insides match. What would the size be of the resulting matrix? But wouldn't you have to go over 10 times and go down 10 times? Am I going to keep track of all that in my head? Probably not. Maybe I could. Probably not. Which is why I wrote out what you guys told me when you were going cross down, right? Long story short, when you're doing matrix multiplication, and we're going to go back to our notes. Long story short, when we're doing matrix multiplication, we're going back to our notes. We need to multiply for every entry in our solution or every entry in our matrix multiplication. Struggle, just a little bit off. We need to multiply each row by each corresponding entry in each column. So the first with the first, second with the second, third with the third, but moving row by column in our multiplication. Moving row by column in our multiplication. Now, it might be helpful, maybe, to put some sort of application problem to this. And we're going to do that. But first of all, I'm going to go ahead and just take a second because there was an example we didn't get to finish yesterday in our notes, right? There was an example we didn't get to finish yesterday in our notes. We were supposed to be finding A times B. So how did I get a negative 2 as a final answer of A times B? Do you guys see where I got? Ready, ready, ready. Eyes up here, eyes up here, eyes up here, eyes up here, eyes up here. Awkward. Eyes up here. If I'm pointing, what am I doing? Multiplying. So what's 0 times 2? Negative 4. So 0 minus 4 plus 2. You see where I got it? So I'm going to do the pointing. You guys do the reading off. Ready? Wait a minute. Hold on. Who am I filling in if I'm first row, second column? The first row, second column entry, right? Okay. So what do you see? 0 plus 5, because you multiply, right? 0 plus 5 plus 12. 0 plus 5 plus 12. You guys finish off the matrix. That would be 17. Ready, set, go. You, yourself, and you. You, yourself, and you. Catch up with wherever you left off yesterday. Some of you might have just been watching. Some of you might have been solving with me. Some of you might have kept going but gotten it wrong. So double check. Do you know what you're doing? And can you finish it off? If you need to quickly reach out to someone in your group, that's more than okay. That's more than okay. Jason, come here, bud. You're all right. Don't worry, I've been teaching before and almost falling asleep, so I get it. Go. Standing up helps me. Are we all here? Yeah. So we're in our notes. Solving that one. Do you have your notes today? Do you have your notes? Or is this homework? Oh, this is notes. Okay, yeah. Go into notes. Good. You guys gonna check my mental math and make sure I'm good because I'm not gonna show any work? Nope. How could you double check this? Calculators, do you know how to multiply matrices in your calculators? I want you to know how to put matrices in. You're going to have to put in A, you're going to have to put in B with the right corresponding orders. Go to your home screen and just do the times in between each of the letters. I want you guys to double check on your calculators as I write out the formulas. But I've had a few people say, so either we both made the same mistake, or maybe a few of you are still trying to figure out what's going on. I'm going to do my pointing as some of you are trying to figure out if you can make or get this multiplication in your calculators. 12 plus 0 plus 3. Negative 6 plus 0 plus 18. 14 minus 4 plus 8. Negative 7 plus 5 plus 48. So what are you doing in your calculators? Talk it out with me just a little bit. Good. First, matrix and then edit. Did you go into A and B, just like this one is? Or you could have gone into B and C or C and D. If you go into A, what size did you have to make A? A 3 by 3 and fill in all of your corresponding entries too. True? Then you would have had to go do matrix edit and make a B. What order is B? Huh? And then fill in the corresponding entries of B. Now what? You have A and you have B. You're 3 by 3 and you're 3 by 2. Multiply. Where? Oh, good. Home menu. So second quit, get out of all the matrix stuff. Wait a minute. Don't you have to get the name for the matrices? Good. You have to go to your matrix and go to name and get A. Then go to your home screen times and then go to the matrix, go get B. And then equals. And if you got it, negative 2, 17, 15, and 12, 18, and 46, someone give me a quick thumbs up if they've gotten it. Okay. It does end up working. Can you go ahead and try B times A and then talk about in your groups as to what your calculator is telling you? Some people don't have calculators. Make sure they know how to use them. Ready, set, go. Talk it out. Do they know how to get there? Do they know how to do the A times B? And then, what's B times A and why? What? What's your calculator going to tell you? Ooh. Does dimension have to do with size?
It says error dimension mismatch.
Ooh. That's what I was waiting for, that mismatch word. But maybe not every calculator does that. I thought they did. Do people in your groups know how to use the calculator? Did you double check with them real quick, especially those without a calculator? Okay, B times A, dimension mismatch. Dimension mismatch is because, wait a minute, guys, do you realize why it wouldn't work? Not just that our little trick of the insides having to match doesn't work, but wouldn't you have to go across and down? What's bad if we start moving? Right? I can go across, but only to a certain extent. Dimension mismatch means it's impossible to multiply. I don't have a third column in order to be able to finish off my cross-down multiplication. So wait a minute, that begs a quick question. What did I tell you guys to do in the back of your homework spiral at the very beginning of class? I just said multiply. What were we finding the whole time? If I had told you something like multiply negative 3 times 5, couldn't you have done negative 3 times 5 or 5 times negative 3? It doesn't matter. Your head could have thought about it either way. But what's the struggle if I say to multiply the following matrix or matrices? What should you have asked me? A times B or B times A? Because they are not necessarily the same, and actually, usually, they're not. So the struggle is, if I give you two random numbers and say multiply, you would never need to ask me which order, because multiplication is commutative for real numbers, for integers, etc. But when I said multiply the following matrices, what should you have asked? Which way? So what did we end up finding? A, B. Could we have done B times A? Why, yes. It would have been a 3 by 2 times a 2 by 3. Would I have been okay? Yeah, but what would my answer have looked like? This guy? Instead of a 2 by 2, it would have been a 3 by 3. So question, is multiplication commutative for matrices? A matrix times a matrix, A times B, will always be B times A. No. In this one, you could have found B times A. It would have been a very different answer, a matrix of a completely different size. In this one, A times B, we found our final answer, but B times A, our final answer is no solution. Impossible problem. None. Struggle. Struggle. Ready, set, go. Find me A squared. What do you mean? 9, 4, 1. It's easy, right? You're killing puppies. You didn't even know you could do that with matrices, did you? Because it's a multiplication error, like a binomial times a binomial. X plus 2 squared. X squared plus 4x plus 4, not x squared plus 4. So what's A squared? Why are all these people saying it doesn't work? Party poopers? They're just pessimists. Or what have they thought about? Yeah, and if you're multiplying two matrices together, A times A, don't I go across as I go? What am I not able to do? I have to go across and down. AKA, isn't this guy a 1 by 3 and this guy a 1 by 3? What's bad? Am I going across? How many columns I go across? How many rows I go down? Doesn't work. So can you square every matrix? No. What matrices could you square? A 2 by 2, a 5 by 5, a 1 by 1. Any square matrix. Square matrix? Why is it called a square matrix?
They're the same.
The rows and the columns are the same. Good. Any n by n matrix can be squared. Any non-n by n matrix, guess what? Can't be. So, what's the big long story short of what we've just seen? A times B is not necessarily B times A. A times B is not necessarily B times A. Ah, stinks. So all of our properties, down the tubes, flush them down the toilet, they're dead. No, there are some that still work. There are some that still work. We can multiply B times C as long as it's possible and then times A, or A times B and then times C. That's legal, the associative property. We can do the distributive property of A times B plus A times C, or B plus C and then A times, as long as it's legal. Similarly, the other way, A plus B and then C, and we can distribute. Scalars are easy. We can multiply AB, then bring in the scalar, or bring in the scalar to A times B, or bring in the scalar to B times A. So there are some stuff we can do, but what's the big thing we can't necessarily do? This guy. Now, did you just hear me say necessarily? Necessarily, which means sometimes it's true. Ready, set? I want you guys to multiply these both ways. Go. Yep. Do you see it's A times I and I times A? What happens if you multiply by the identity matrix? Why is it called the identity matrix? If you add, everything does not stay the same. We need a zero matrix. Why is it called the identity matrix? It's not the additive identity. Maybe it's the multiplicative identity? What's A times I and I times A? Cross down. What's A times I and I times A? Practice your cross down. What do you notice about 3, -2, -3, 1, 0, 4, -1, 2, -3? It's maintained its identity. It's the same original matrix. Does that make sense? I think that's what Robbie was saying. It's kept its identity. Nothing changed, right? Did anything change? Mm-mm. If something did change, your math was wrong. Did you try going the other direction as well? So if you do A times I, you get A. And if you do I times A, 1 times 3 is 3 plus 0 plus 0. -2 plus 0 plus 0. 5 plus 0 plus 0. Do we see a pattern? Oh, looks like a 3. Lo siento. It's going to maintain its identity no matter what. I'm going to have 0 plus 1 plus 0. Oops. I lost my plus in there somewhere. Got to having too much fun. 0 plus 0 plus 0. 0 plus 4 plus 0. And my last one's going to be 0, 0, -1. 0, 0, 2. 0, 0, -3. The identity matrix is the matrix such that if you multiply him by a square matrix of the same size, you will result in the exact same result. So, A times B equals B times A. Nope. Unless it's with the identity, then yes. 0, 0, -3. Is that what you mean? Or do you mean, oh, this one? 0, 0. Oh, because I can't multiply. It's 5. Thanks, Sam. Thanks, Austin. Thanks. You guys see any other mistakes when I was going too fast? Okay. Matrix multiplication. Ooh. Can this be used for something? All the stuff that we've talked about with matrix multiplication today? Matrix multiplication can show systems of linear equations. What? Hey, you know how we used to do augmented matrices in section 7.3? A little bit in section 8.1? Well, we did RREF actually a lot in section 8.1. What were we actually doing? We were skipping a step in analyzing, because we hadn't reviewed multiplication yet, in analyzing a system of equations. Technically, if you have all of your x's and y's and z's, or x1s, x2s, x3s, you can factor out, ooh, you ready? You can factor out the multiplication that was done. Cross down, cross down, cross down. Technically, when we made our augmented matrix, we factored out the variables, which we can do as long as all of these are matching. We can take the x1 out, take the x2 out, take the x3 out. Taking away all of the variables from the coefficients, we had all the coefficients, we had all the constants. We set them up next to each other and then row reduced. We might see a little bit behind the scenes as to why it works and why we were trying to get back to the identity matrix for RREF as we dig a little bit deeper into matrices themselves. But you guys have already seen how we can do an augmented matrix. We take all the coefficients. We were just saying, ignore the variables, get them in order, and then ignore them. But the reason that we ignore them is because technically we could factor out all the variables. What's remaining is all nice and systemized, all nice and organized in a matrix sort of fashion. And then, well, we worked with it, but maybe we'll see a little bit more as to why in just a second. I'm going to dual page, because this one isn't necessarily new information. It's just kind of showing you, hey, when you have a system of equations, you can take out all of the variables and just deal with the resulting numbers that are organized well. And this brings us up to, remember how a second ago I was like, I wonder if all of this has meaning. Let's talk about milk. Being sold at a local dairy mart. We don't have a lot of dairy marts in California, at least not in Southern California. But there are places back east that are actually called milk stores. I know it sounds kind of weird. But it used to be a place where you literally just go and get milk. Now there's stuff now, it's kind of like a 7-Eleven-ish where you have like, I don't know, refrigerator sections with like chocolate milks or like Gatorades or waters or things like that too. It's kind of like a convenience store. But a local dairy mart, I know it doesn't really make a lot of sense for us, but it used to be a thing and it still is in some parts of our country. At a local dairy mart, the number of gallons of skim milk, 2% milk, and whole milk sold over the weekend are represented by matrix A. I want you guys to think about what might the rows and the columns be representing. Has to represent something. Right now they're just numbers, but the numbers have some sort of meaning. Take a second and ponder as I answer Kyle's question. Oh, I thought you had one.
Oh, I did, actually.
Yeah.
I think there's one.
Oh, is there one?
In Devonshire and...
There's like a drive-through convenience mart up in Santa Clarita, but you guys wouldn't necessarily know this. Oh, maybe it is. Maybe it is a dairy mart. I'll have to go check it out. Devonshire. It's okay. Sounds a little more British. Anyway, has anybody thought about what could be labeling the rows, what could be labeling the columns? Robbie? Okay, so we have skim, 2%, and whole milk. Those are 3 types of milk. Struggle is we have 3 rows and 3 columns. Well, stink. What's the other 3? Not the gallons of. Kyle? Yes. Friday, Saturday, Sunday. Because you think Friday night, like the weekend started. So for a business, the weekend is like Friday, Saturday, Sunday. Unless it's like a 3-day weekend, but I mean, how often does that happen, right? So Friday, Saturday, Sunday is like normal business weekend hours. Okay? So which one's which? Well, let's keep looking and let's keep reading and try to figure out, so are the columns the types of milk and then the days, or is it the types of milk and the days? Okay, hold on. Down here. The selling prices in dollars per gallon and the profits in dollars per gallon for the 3 types of milk sold by the dairy are represented by B. Okay, well, hold on. How can we label B then? Okay, the columns are going to be our group of 2, right? Selling prices and profits. So I must have, and it makes sense that selling price would be more than profit, right? Because you have to pay for the milk. And we have the profit, okay. And so what must, if those are the columns, what must the rows be? Types of milk, we said there are 3 of those, so that'd be skim, 2%, and then whole. It's weird that skim is the cheaper, it's usually backwards these days. But anyway, coming back. Well, I guess no, like more almond milk, coconut milk would be the higher priced ones. Organic milk, oh my goodness. Chocolate organic milk. Anyway, coming back. So does that help us with this? How? The milk or the rows? If you multiply to organize all the information, didn't what Was the rows need to originally be the columns? Skim, 2%. If you guys notice, letter A says compute A times B. Now, guys, these are nasty numbers. You can go ahead and start throwing them in your calculators if you want. But if you check it, give me one sec. The number of gallons of skim could match up with the selling price for skim, and then 2%, and then whole. Matrix multiplication would go over as it goes down. I would need the rows, or I should say, the columns as I go across a row, the columns to match up with the rows in order for my information to be.
I know some maybe weird. Could we scale multiply 100 to get rid of the decimal, or would that just completely?
You technically could, but then remember at the end with our monies, we'd have to be thinking of them in terms of cents instead of dollars, which would be kind of awkward. Does that make sense? But some people do that. Well, my mom used to work at like a doctor's office, and for invoicing and billing and things like that before the programs had super developed, if she would never use decimal places. Why? Because it would take an extra step of having to hit the decimal point. So she would just always do it without decimals, and if it was something like $5, she would put 500. And then at the very end, she would just think in her mind 2 decimal places for whatever's there. But most of us don't think in terms of cents, we think in terms of dollars. So unless you were putting in a huge data entry sort of thing, where going to the decimal place might throw off, will slow you down, number one, and number two, might take your numbers off of like the keypad. Usually we put it in. So I know you guys are actually doing this in your calculators, but I want you to think through one more time what you're doing. What you're doing when you multiply A times B. We can go ahead and say, hey, this is a 3 by 3. We can go ahead and say, hey, this is a 3 by 2. We can go ahead. But they asked us to what we're actually getting. And you guys might be like, okay, well, what's the big deal? I don't really get what's going on. Do you realize that a lot of stores sell a whole lot more than skim 2% and whole? Right? Right. But even like, get out of the Dairy Mart, just go to a local grocery store. Why on earth would they want to keep track of what they're selling, how much they're selling at certain prices during the week, etc.? Yeah, or perishables, right? Do you guys know that people at Trader Joe's, like basically their main job description is just to keep track of what's on the shelves and what they need to order in order to have the store stocked, but to not lose money on perishables that go bad? And they have it split up by sections, like a fresh section and the meat section, and then there's like the produce section, and there's the section, and there's like the dairy section, and then there's, and it's a crazy hard job because they're always say we don't want food to go bad for customers to have. Does that make sense? It's always. Now, I'm not saying they all necessarily use matrices. Some of it is just getting really used to the job and keeping an eye open and seeing what's there, what's not, and balancing. But it is very helpful for a lot of businesses to keep track of what they're selling, how much they're selling, when they're selling it, etc. So the matrix multiplication is saying, hey, I can analyze all of this by just plugging in the numbers into this matrix multiplication and saying, okay, we have all our different products, how much we sold on different days like Friday, Saturday, Sunday, right? When you guys plugged in and got A times B, just really quickly, what numbers did you get?
571.
Actually, let me steal someone's calculator. 571.8? Uh-oh.
Wait, no, never mind. I did 571.8.
Okay, keep going.
206.6. 798.9.
Okay.
288.8. 936. 337.8.
I'm going to add little zeros because this is all money, right? What's the interpretation of this chart? The profit made from each one over the weekend? So wait, is this the combined profit from all 3 of the milks just for Friday? Close. It's the skim profit plus the 2% profit plus the whole profit. What is this? All the profit from all the milks on Friday. You see it? And this would be all the profits from all the milks on Saturday and all the profits from all the milks on Sunday. Well, if those are all the profits, these are all the money that was brought in, right? The money that was brought in on Friday, Saturday, Sunday. Question, when do most people seem to buy milk? Sunday. When do you better make sure that you're in stock? Sunday. Wait a minute, but where did all the milks go? Why is it when we multiply matrices, we end up with the first and the last, and this one ends up disappearing? Because the skim and the 2% and the whole all got combined. This multiplication? The matrix multiplication said, hey, we'll line him up with who they need to be lined up with, and we're going to accumulate or add them all because you want the overall profit. You want the overall profit from all of them put together. Just a quick little peek at, oh, this is how I could use a matrix. And this is why the inner quantities need to match up, because cross down, my columns across, my rows down need to correspond for my accumulation or my addition. Interesting. This is the end of section 8.2. Yeah. Oh, remember, we didn't know at first. At first, Robbie was like, hey, there's 3 of these, and then someone else, Kyle, was like, hey, there are 3 of these, and we didn't know which one was which. But as soon as they came down here and said there's selling price and profit, that's the only 2. I knew that had to be columns, Kim. And so they said, hey, selling prices, profits, and then types of milk. So I knew if those were selling price and profit, these had to be types of milk. And if I'm multiplying, these have to match up with those. So I worked my way backwards. Yeah. All right, cool kids. We were technically supposed to start section 8.3. So I'm just going to show it to you just for a little bit. We're going to pick up right here tomorrow when we go over, after we go over questions to homework. I want you guys to take a quick picture of this if your phone is close so you can get your notes set up ready to go tomorrow. I'm not going to give you a lot of time. Maybe I'll have it up for the few minutes before the bell. But if you remember, we've been talking about a lot of things this year about inverse operations. And in Algebra 1, you would have seen something like x plus 2 is 7. Solve for x. Ooh, I need to minus. But this year in pre-cal, we see e to the 2x equals 4. We need to get to x, and now we should think the inverse of e is ln. But either way, we still need an inverse to undo, right? Now this one wouldn't get us all the way to the answer. Technically get us 2x is equal to ln of 4. Keep solving. But we need inverses to undo, right? So if we ever had any sort of matrix equation where we had to undo a matrix, and maybe some of you remember I said something about the end of the chapter being cryptography, coded messages. If a message has been encoded with a matrix, we have to decode with a matrix. We have to undo what has been done. The only way to do that is with an inverse. So if nothing else, the only way to decipher the hidden messages, which is going to be just a hint, the bonus on the test, deciphering a hidden message, you're going to have to know how to do inverses. Whoa! You're going to have to know how to do inverses. An inverse is a matrix that undoes. And if you notice, matrix multiplication with inverses also goes that way. But that means an inverse must always be the exact same size as the original and a square matrix. How will we show these inverses? What's going to happen when we multiply if this is an inverse? Any ideas? Hopefully, we get back to the beginning. Bye, cool kids. See you later.
1, 0, 0, 1.
Matrix multiplication, if you're stuck at all, if today didn't make sense at all, come in, sit down, whiteboard. You got to swallow your pride and say, I need to be shown. Bye, guys. Pre-cal starting row echelon form today.